I am presenting on an open source toolchain for Atmos transcoding and layout agnostic playback. I'm a graduate student in the Media Arts and Technology program at UC Santa Barbara. So I'm going to be talking about this project, the Cult DSP Spatial Toolchain, the issues that motivated this project and how I'm addressing it, and why this matters to developers and creators at Linux Audio Conference. So the issue that I identified was that industry standard object-based spatial audio is extremely powerful. The technology is great, but it's locked inside proprietary ecosystems. Dolby Atmos was the main motivating focus of this project. It dominates music, film, and streaming, but it requires proprietary renderers and DAWs to engage with it. The ADM BWF audio definition model is what Atmos is built on. It's flexible as a scene format, but it's really difficult to interact with or render in open source research and development contexts. The research facilities that I do my graduate student work in back at school use irregular loudspeaker arrays and custom software packages that are generally incompatible with standard playback assumptions for playing back Atmos files. So there's no obvious pipeline to go from commercially relevant spatial audio data to flexibly playing back these scenes, interacting with them in installation contexts and creative development of these software packages. So that's kind of the motivation behind this project. I wanted to touch on some basic spatial audio representations for those who this isn't their field. Object-based spatial audio is when you take an audio track and represent its position with scene metadata coordinates, and then render the object back at playback time. The key here is the objects are separate from the speaker layout, and with Atmos, the idea is kind of one mix fits all. Instead of doing a channel-based mix where audio is mixed to a specific channel output, those are really simple to decode, but you're making a bunch of different mixes for different environments. And then there's scene-based audio with ambisonics or higher order ambisonics, where you're encoding your track into a sound field, which is layout independent and has different decoder requirements. I'm not going to touch on wave field synthesis and beamforming. It's outside of the scope of this presentation. Modern next-gen audio systems are generally hybrid. ADM, along with MPEG-H and IAMF, which I'll touch on, are capable of carrying all three types of object-based, channel-based, and scene-based audio. A little more on this format before we dive into what I've built. The audio definition model is an XML-based schema, and that XML is embedded in an arbitrary channel interleaved wave file, and those files can get extremely large. These XML files describe the object's movement over time and relationships in terms of trajectories and timing. It's used by Dolby Atmos, and there's a variant for Sony 360 Reality Audio. Other relevant formats are MPEG-H and IAMF, which have catered a little more to the open source communities and interactivity, but they're not as widely accepted in terms of commercial streaming. All right, I just wanted to touch on existing solutions before I explain what I built. There's basically a slew of different options for different pieces of the puzzle when it comes to decoding these files, authoring them, rendering them. It's a difficult space to navigate, and in terms of both hardware and software, there's a lot of proprietary options. There's open source options that work pretty well. But as a developer trying to get into this space, when I was looking into this, it was very unclear how to begin. It's very fragmented, and not everything, there's really no solutions that like put every piece of the puzzle together conveniently and let you split them apart. So that was what I'm trying to tackle here. And I'll explain what is in the Cult DSP spatial toolchain and how do we use it to close the gap between the spatial audio formats and tooling used in industry and used by research and developers. I don't feel that there should be a gap there. So that's the motivation behind this. So there's three main infrastructure components here with the goal of making industry standard spatial audio usable outside of proprietary ecosystems. I have the cult transcoder, the transcoding utility for ingesting your ADM files, extracting and normalizing the scene metadata, and exporting them to an intermediate scene representation, which I call Lucid. It's human readable, it's JSON, it's super simple. And then those are used in Spatial Root, which is a layout agnostic real-time and offline playback engine for any loudspeaker array. The design principle here is that translation and scene representation, your playback and rendering, and authoring are all separate but interoperable roles. I have a little breakdown here. The transcoder, basically the gist of it is there's different scene inputs and there's different scene outputs and different packages that can go in and out. Spatial Root takes any of those packages in or out, uses the transcoder, and then renders spatial audio. It uses a speaker layout as well to decide how that works. And Lucid, it's not an input and output breakdown, but goes over how we define these scene metadata structures and how it's consumed by other components of this tech stack. This is basically reiterating that same idea, but visually left to right. I'm going to dive into how the transcoder works. It's a C++ library and CLI with an optional GUI in the Spatial Root app. For inputs, it can take in ADM or my custom Lucid files or Lucid package. The Lucid package in this case is your Lucid scene file plus your mono stems. So the transcoder parses your scene data into an internal model that's not yet the JSON. It's a C++ struct, and then it writes to your target scene format. So you can go from ADM to Lucid or a Lucid package, or you can go from a Lucid package and have all of those stems normalized and resampled to be Atmos compliant, and then have that scene file rewritten as an ADM XML and have that authored as an Atmos master file, which can be brought into a DAW. So there's different paths here, but the gist is one format can become another format, and it's really easy to move between them. An important part of this process was also adding sort of a reporting file if there are any transcoding issues, if there's any inconsistencies with coordinates or anything like that. Generally, there's not, but I think it's useful for developers to be able to debug that. A little bit on this scene format I've been talking about. Lucid stands for Lightweight Universal Spatial Interaction Data. It's a node-based JSON scene format that stores everything as ordered time frames. Each frame has nodes, and it represents the object's state changing over time. The main object nodes are audio objects, which have your Cartesian coordinates, direct speaker nodes, which are basically your fixed surround channels, and your low frequency effects channel. I've also added auxiliary nodes because I envision this format being useful for different interactive media contexts. So things hypothetically like spectral data or agent state or geometry can be attached as child nodes to a primary audio object node. This is also a lot easier to debug than the raw ADM XML. And notably, this format is ordered in frames, whereas the XML for ADM is kind of more object-oriented. Why did I bother making an intermediate scene representation? It's a lot simpler to read. It's an easier intermediate target for development, and it's language agnostic. The repo is just a JSON schema plus a human targeted README and an agents file for people that are trying to quickly embed this in one of their projects. And I was really focused on making a deployable scene file for interactive media contexts. a use case like easily capturing data from a multimedia installation and using that to drive object positions to author an Atmos file. That was kind of uh, the vision for this, or having web apps that stream in lucid scene packets is something I'm also working on. Just being able to capture arbitrary state over time and use it to inform spatial audio data. So discussing the engine that makes this all actually tangible and audible. Spatial Root can render any of your spatial audio scenes that is, a supported format to any speaker layout. You input your scene, you give it a layout, and it basically just renders it. You can choose real-time playback or offline batch rendering. The panning algorithm is distance-based amplitude panning, which I'll touch on more later. And there's no base management. I opted for using mixes that directly route to the low frequency effects channel. I found that useful for Atmos, and I talked to a lot of engineers about that, and generally there seemed to be no issue with that. There's some runtime controls exposed, like gain and trims, and there's a focus parameter for controlling localization and the distance-based amplitude panning, along with an elevation mode. Most of your Atmos mixes go to ear level, so this allows that field to be rescaled to ground level if your system has that vertical capability. And mostly this is deployed in UC Santa Barbara at our various media labs there. The API has a really consistent initialization process, and it's used by every surface. It's used by the GUI, it's used by the CLI, and any host apps that I'm testing this out in. Its real-time streaming model is sort of double buffer approach per source. These files can get really big. You might be reading from an 128 channel interleaved file. So this was the most sustainable model for doing this. The runtime parameters are adjustable without restarting playback, and you can keep them consistently between sessions of swapping out audio files, which is nice. There's really comprehensive diagnostics, and you can control all the parameters via OSC, and you can configure that port. I went with distance-based amplitude panning, which renders a virtual source by distributing gain across the loudspeakers according to their distance from the source. It performs really well on irregular arrays and does not require a sweet spot. There's a focus parameter to tune the localization, which works fairly well. And I inherited this from a library in our graduate department that had a DBAP implementation that wasn't totally normalized, and I've kind of revised that to work extremely well. I want to touch on VBAP and LBAP, some alternate panning methods, which I opted to not use in this first version of this software. I just had a lot of issues with getting VBAP working properly. With fast-moving objects and irregular spaces, I think there were often issues with finding valid triangles that objects could be panned into the VBAP space. So I kind of just deferred that for future work, and DBAP just worked better perceptually. Layer-based amplitude panning is really nice for spherical layouts with elevation rings, but I didn't have a consistent implementation of that either. So those are all future work. I have an example of, on the right, a blueprint from the Alisphere, our media lab, and then on the left, a snippet of the JSON layout file. Super simple. I was originally handwriting these, and then I built a super simple web tool where you can kind of construct them and export the JSON. Or if you have a complex blueprint, I also have a ChatGPT web page that you can just dump your blueprint into, and it'll give you some version of this that you can import into the layout tool. Spatial Seed is a development experiment I wanted to talk about. It's not directly part of the tool chain, but it uses the toolchain. So it was kind of the first project where I experimented, like, can I build something new with this? The goal here was to build a procedural authoring system. Right now it's a Python prototype, whereas everything else is C++. Um, Basically, the way it works is you upload a bunch of stems, and those are kind of analyzed and split, and if they're stereo, they're split to mono. It uses Labrosa to run feature extraction and classify everything, and it compares that to a database of instrument and mood profiles I have, and then uses that to generate object positions. Basically, that is then written as a lucid scene file, and you can choose to export that as an ADM Atmos master file, where you can bring it into a DAW for refinement. So that was also a motivator in choosing to engage with Atmos and choosing to engage with the proprietary world. The fact that you could take the things you've created and bring them into a DAW on someone else's device, and it'll completely recreate the session with all the panning automation trajectories. I think that's super useful. So in this case, you can prototype this procedurally authored scene and then refine all the trajectories in your DAW if you'd like to do that. There's kind of a fun interface here for controlling the aesthetic and dynamic sort of role of the mix here. But it's really just a simple UI that determines how much motion and which genre of instrument will get selected. It's really a prototype just to test out what can be done with the cult transcoder and the lucid scene file. I want to talk a little bit about where it's implemented and a couple development considerations. This was targeted at being cross-platform, which I'm sure is a theme at the Linux Audio Conference. Everything's really lightweight C++ dependencies. A lot of work went into stripping everything down as much as it could be. If you're building from source, all the dependencies are fetched nicely within a init script. If you're downloading the Mac or Windows package, I don't have a Linux download yet if you're not building from source. It's like less than 4 megabytes. And one consideration is that depending on your core audio backend, the audio might render slightly differently. I haven't spent a lot of time like optimizing for specific drivers. So like Wasapi and Mac Core Audio, for example, like handle fast moving objects slightly differently. Speaking of which, this was a big development consideration. Due to the size of these files, I opted for this prototype at least to have spatial root compute the spatialization at the block rate, not at the sample rate, which is something I would like to change in the future. But due to that, fast moving objects that would move at aggressive angles would cause audio artifacts in the distance-based amplitude panning implementation, lots of clicks and buzzing, and sometimes even channel relocation. So I implemented some fixes for that are in the engine now, where positions will be readjusted in real time if they're too aggressive, and there's some interpolation happening as well. So everything is all safe there now. You can pan 100 objects moving around really fast, or 128, I suppose, is the limit to be Atmos compliant. It's implemented in a few media labs at UC Santa Barbara. TransLab is a rectangular space. The Allosphere is a sphere, 3-tiered ring space. It's implemented there in a multimedia shader playback plus spatial rendering app. And more implementations, more deployments are in progress currently in Santa Barbara. In terms of functionality, spatial root is totally functional, but no formal perceptual evaluation has been undergone. Cult and Lucid, so the transcoder and the scene format, have been validated across DAWs and official Dolby tools in terms of import validation. Broader developer adoption I'm listing as future work. Spatial Seed is an interesting prototype. It's got kind of mixed results. The placement engine skews very heavily to the front of the listening field, and the instrument profiles need more expansion, as well as the gesture engine being somewhat uninteresting. The evaluation framing here is on practical system behavior rather than spatial perception testing. For future work for this project, in V2 of the Cult transcoder, I would really like to add support for MPEG-H and IAMF or Eclipse, as well as ambisonics export, which they're already and binaural export. Libraries already exist for the ambisonics and binaural portions. I just haven't integrated them yet. Spatial root, there's a lot I'd like to add. More panning algorithms, sample accurate spatialization, possibly rotation, real-time convolution, and visual monitoring. In terms of Lucid, the scene format, I think I would like to experiment with it in interactive media contexts and game engines and Macs and things like that. And Spatial Seed, I would just like to make a proper tool rather than a prototype. I think it would be useful for people who need to quickly create a spatial mix and bring it into their venue while they're testing things out. So to wrap things up, ADM, the audio definition model and other spatial formats can be treated as flexible scene data rather than just fixed format deliveries. The Cult transcoder and Lucid provide a portable scene translation and representation layer across this toolchain and for other developers. Spatial root enables layout agnostic playback and engine embedding for regular venues. Spatial Seed shows how the same infrastructure enables tool development and interactive media. I've got some other projects I'm working on as well in that respect. And together, they form an open source foundation for connecting industry standard object-based audio with research, creative, experimental environments, and software development. And that is all I have. And I wanted to open it up for questions if there's time. Here's a QR code for the GitHub page. And thank you so much.
So just in between the question.
Yeah, can you run the render inside the draw? In an audio workstation, yeah.
The renderer is just for when you already have an export. So tooling already exists within DAWs. That's something I would like to add support for, but at the moment it's DAW independent.
That's Shemiko.
Hello. Are there extensions possible to the spec? For instance, ADM doesn't support horizontal or vertical span for audio. Does it allow for extending, the metadata that comes with objects, for instance, for further advanced rendering later on?
Yeah. Yeah, well, at least how I'm interpreting the question, what's nice is you can write straight to this Lucid scene format from if you have your ADM data and you'd like to do more with it, you can author straight to this Lucid scene format, bypassing any hurdles there with ADM, and then just render straight from that if you'd like to. I don't know if that made sense. I can reiterate.
Yeah. Cool. Thank you. Anybody else? No?
I just have one. So in keeping with the theme of the conference, you mentioned the use of LLMs for sort of configuration. Could you talk a little bit more about that?
Yeah, so it came up for me. I was implementing this engine in a really bizarre space where there was 3 different rooms that were multi-tiered and all kind of connected but open. And I did not have a lot of time to create a configuration file. I had like 5 minutes, and I basically gave it to an LLM with a bunch of prompts, and it approximated the layout file a lot quicker than I would have. So that motivated that use case, that if someone has a really complex blueprint where they're not just looking at a system diagram, they might have scattered PDFs. They can give it to this ChatGPT bot that already knows what to do, and it'll create the JSON, which you can then import into a web tool and refine it further.
Thank you very much.